than that. They don't just give us information about how students are doing. In fact, tests can produce learning. And that is the case even if you don't use tests formatively. Obviously, you should sort of look at what the tests are telling you and then tailor your future teaching based on that. But even if you don't, the research suggests that the very act of testing students helps them learn better. And the reason is that it forces them to use their memory to recall something that they've come across before, and that in itself strengthens their memories. And this effect means that students are likely to learn more from future learning episodes. It means that they can use what they already know in a wider range of contexts. And there's even some research suggesting that they can organize their knowledge better after having been tested on stuff they have encountered before. So that's the testing effect. And retrieval practice is really just about harnessing the testing effect. So here are a couple of bits of information that I've pulled straight from Retrieval Practice by Kate Jones. She's got a number of books that you can see at the bottom of the screen there, all about retrieval practice. But what retrieval is simply the act of recalling learned information. And the important part is that this is done with very little or ideally no support. So it's not the same as having an open book test and answering questions with reference to materials that you've got access to. And the second quotation there that you see is kind of getting at what I said before. Using your memory shapes your memory. It's an important thing that has been sort of supported by lots of bits of research. So that's the basics of what retrieval is and why we should do it. Just a couple of bits of vocabulary here. We've got retrieval storage, which is about how well something is stored in our long-term memories, and retrieval strength, which is about how easily we can bring that information to mind. So if we look at that graph at the bottom, we can think of bits of information in our heads as points on that graph. And obviously what we want with stuff we're teaching is for things to be towards that green cross, something that's got a high retrieval strength and high retrieval storage. If I just give you some examples, the red cross has got high retrieval strength and very low retrieval storage. So that would be something like, what did you have for lunch today? So I can certainly remember what I had for lunch today. That comes to mind very quickly, but that is not likely to be embedded in my long-term memory. And if you ask me tomorrow or next week what I had for lunch on this particular day, I won't remember. If you look at the blue cross towards the bottom right, that would be something like, let's say, 10 years ago, there was a track that was in the charts, and I'd listened to it a lot. I'd hear it on the radio. Maybe I really liked it, and I listened to it on repeat. But for some reason, I haven't heard it since. And if someone played it to me today, I'd probably recognize it, but I might struggle to name the artist or the album or anything like that immediately. But if given enough time, it would probably come back to me. Or if someone told me the artist or the name of the track, I'd go, oh yeah, of course, yes, I remember now. So that would be something where my retrieval strength was low. I couldn't recall it immediately, but it was there in my long-term memory. So those two are not ideal. What we want is high retrieval strength and high retrieval storage to certain types of maths. And these are typically the basics that we want. We want things. We want students to be able to sort of just do at their fingertips. A bit like knowing your times tables. Just want to cover a couple of other concepts because there's sometimes a bit of confusion between what these mean or whether there's a bit of overlap between these different contexts. So the other concepts we're looking at on this slide are interleaving and spacing. So interleaving is about mixing material from different areas, different topics over a period of time. So sort of the classic bit of research on this was about getting students to identify differences between works of art by different artists. And the test subjects were better at identifying these artworks when they looked at lots of different artists, one after the other, rather than one artist at a time. So the sort of mixing up helped. It helps draw attention to bits that we want to compare, for example. So if you look at the little graphic on the right, sort of doing A, B, C is more of an interleaved approach, whereas the second one there, where you've got A, B, B, C, that's called a blocked approach. And in various contexts, interleaving is something that is beneficial. Now, typically, interleaving is about encountering new material. And it's the same kind of thing with spacing. Now, spacing is about where learning is stronger when you spread information apart over time. And again, this is really about new material. But that doesn't mean we can't space when we retrieve things, right? That's a different thing, but spacing is actually useful when it comes to retrieval, sort of necessarily. You need to, something has to have been encountered once for you to be able to retrieve it later. And the research suggests that there are sort of various time periods where it is useful to retrieve things, often a day or two later, and then a few weeks later, and then a few months later. And it ties into sort of slowing the decay that you see on the Ebbinghaus forgetting curve, which you may well be familiar with. But retrieval is really about stuff that you've already encountered. Kind of self-explanatory, really. You can't retrieve something that's new if you've only just met it. So just want to talk about what retrieval practice is not. So what's not involved in retrieval practice. So if you are presenting worked example problem pairs, for example, and you've got my turn and then your turn, left and right of your board, for example, students doing something like that is not really retrieving. They're not retrieving what they've just seen you do. And that's fine. We're not saying doing my turn, your turn is a bad thing. In fact, we've had a webinar in the past where, we were promoting this. So I'm just sort of saying this is not retrieval practice. This is its own thing. This is using example problem pairs for a specific reason. But the reason this is not retrieval practice is this because, first of all, it's too recent. And second of all, students are not doing this with little to no support. They've actually got a lot of support because they've got a fully worked example. They've got the teacher's my turn showing on the board while they do the your turn for themselves. So they've got a lot of support there. Also, if you're setting homework where students must first watch a video, this is not retrieval because, again, they've got that support. And the idea of retrieval is that they do this with as little support as possible. So this is not to say that homework where students must first watch a video is bad. There may be perfectly valid reasons why you want students to watch a video first and take notes, etc. That's something that Hegety Maths tends to recommend. And all the sort of major homework platforms that have videos give you the option to force students to first watch a video. Again, there's perfectly valid reasons why you might want to do that. Similarly, creating revision notes or reading knowledge organizers, that in itself is not really retrieval. Although we can use knowledge organizers for retrieval, which I will come to on the next slide. So as I've said, all these things that I've mentioned on this slide, they may well be desirable at various times in the classroom, but they serve different purposes. They're not retrieval in and of themselves. So what if we do want students to engage in retrieval practice? What can we do? Well, here are some suggestions. For me, the easiest is simply asking lots of questions. So whether that's cold calling or maybe using mini whiteboards when everyone's allowed to use mini whiteboards again, that's a sort of really easy way to kind of do some quick fire retrieval. There are lots of retrieval resources you can use online. I'll just share a few that you've probably come across before, at least a couple of them anyway. So here is, the classic, probably the most popular thing out there, Corbett Maths 5-a-days. They're sort of broken down, really good if you want to print them out. I'm currently working in alternative provision, and the students I've got, they've been used to this, for the whole time they've been in that, they kind of kick off if they don't start with a 5-a-day. So this is a really good settling activity, which, you're probably all familiar with. There is also mathspot.com that has loads of resources, but particularly these do-nows. And I quite like the mixed one, which is quite good for probably younger students, lots of sort of little tasks. And then a little bit of shameless self-promotion. There's one that I've created, it's also completely free. It's called Top Topics on my website, where you can pick and choose which types of question you want. So here I've just put up six questions. And the reason I find this useful sometimes is that I can sort of really easily adjust the difficulty of things. So, perimeter area volume, maybe I just want something a little bit easier. Just find the circumference, for example. But also because if I find that students aren't able to do these, and they just need a little bit of extra practice, I can very quickly regenerate the question by clicking on the answer, and it just generates a new one. If they find stuff easy, I can just quickly give them a more tricky one, or just generate a new question like that, which I find really useful. Okay, going back to this, I would also suggest low stakes quizzing, which you're probably familiar with, or you may have come across if you've read Craig Barton's books. These are ways of getting students to retrieve. And if you do low stakes quizzing, a good thing to do alongside that is to ask students to give a confidence rating on each question they do. So if they've answered a question and they're really confident they've got it right, they can give it a high rating. If they're not quite sure, or they're just guessing, they're going to give it a low confidence rating. And the point of doing this is that if students are very confident about something, but they end up getting it wrong, then when corrected, they experience something called hypercorrection, which is a good thing. It makes them more likely to learn from that mistake. So learning from high confidence, questions where they were highly confident but still got wrong, is a good thing. So getting them to reflect on each question and how confident they're feeling is a sort of simple thing that you can do. But it just does take a bit of a culture build up to get students to do that. And while I'm talking about culture, encouraging students to self-test sort of in class, at home, is a really good thing. It just harnesses this, the testing effect, like retrieval practice does. So it's not something that just has to be done as homework. You can be doing it in class by getting students to make up questions and see if they can answer them, things like that. Now, a couple of other things where we can talk about retrieval in the maths classroom, and where it can be a little bit different from some of the more generic things that you would come across in books about retrieval practice across all subjects. Maths particularly has a lot of techniques that aren't sort of very specific to the subject. And I'd like to consider the idea of retrieving a technique. So I'm going to give you a couple of examples. Here is an example of what's called a continued fraction. This is not something that students formally need to come across, in this country at GCSE, but it's something that you can do as a bit of an enrichment activity, or it's something that you can get students to investigate just to help them get better at working with fractions, once they're fluent in the basics. But what we can do here is use it along with something else for retrieval practice. So let me start by this. Can we work out what x is, given that it's this continued fraction? It kind of goes on forever. We've got 1 over 1 plus 1 over 1 plus 1 over 1 plus, and so on. Well, the thing to notice here is that what we've got in yellow is actually the same as the original fraction, right? This thing in yellow is just x. It's 1 over 1 plus 1 over 1 plus, it's the same as the original thing. So x is in fact equal to 1 over 1 plus x. And this observation is kind of the key to working out what x is. We've got an equation here that we can then solve. Okay, I'm not going to go ahead and solve it. The point is to see that this is a technique. And this is something that I've done with students at one point, and then sometime later, I would expose students to this. So not in the same lesson, weeks later, and I would try and get students to do this with as little prompting as possible and as little support. And it looks completely different. It's not got fractions for a start, but what we've got here in this nested radical or nested surd is something that repeats itself forever. So it does have that similarity, and students can, if they remember the technique for the first one, do this. Now, if they need the support, of course, I'll provide it to them, but here's a sort of idea of retrieving a technique. And yeah, as you see, what we've got there in green is actually the same as the whole thing. So we can replace that with just x, which is what we've called this. And then again, we've got an equation that we can solve. It would turn into a quadratic when we square both sides. And yeah, so there's just a quick example of retrieving a technique. Now we'll come back to the problem I had on the first slide. Here's a tweet that Naveen Rizvi put out about a month ago. I fill a glass with orange juice and lemonade in the ratio 1:4. I drink a quarter of the contents of the glass, fill the glass with orange juice. Now what's the ratio of orange to lemonade in the glass? And this is quite a popular tweet. It got lots of replies, lots of likes. Naveen was just interested in seeing how different teachers would approach this. Now, it turns out that this can be answered quite simply, but a lot of people were using algebra and sort of making it quite complicated. Now, that's not a criticism. It's not necessarily obvious that it could be simple. Maybe for some of you it is, but I saw the simple route to this, not because I think I'm particularly bright or I'm just a natural at this kind of thing, but because when I saw this, it reminded me of this question that we had on the first slide, this Cayley Olympiad question. Now, the solution to this Cayley Olympiad question, or the quick way of solving it, is to realize, if you've read this, in fact, for those that joined a little bit later, I'll just pause for 30 seconds while you sort of read the question again. Okay, so the key to the question is that the whole 1 litre bottle of orange squash ends up in the large container in the end, because he keeps pouring, the bits from half the bottle, it keeps getting diluted, but keeps pouring half the bottle into the large container. But at the end, he empties it completely into the container. So all of that 1 litre of orange squash, concentrated squash, ends up in the large container. And that is 10% of the final mixture, because that's what it says in the last sentence. So we know that the large container in the end contains 1 litre of orange squash, and because that's 10% of the whole thing, it has 9 litres of water. And then the question is, how many times has he filled the bottle from the tap? Well, the 10 litres in the large container has that 1 litre that came from the final pour, after which it wasn't refilled. But before that, half a litre was being poured at a time. And for that to happen, the bottle must have been filled 18 times, right? Because 9 litres was being, the other 9 litres came from half a litre, one fill at a time. So 18 times. And that is kind of the quick way of seeing this that doesn't involve loads and loads of hard work. And I remember when I first came across that problem, I did it quite a long-winded way, and I totally missed the shortcut. But ever since I saw that, every time I see anything vaguely similar, I spot the shortcut straight away. So this is not kind of a conventional little bite-sized chunk of knowledge that you might put on a knowledge organizer, for example. It's a kind of strategy, a technique, a trick, maybe even, but it serves a purpose. It comes in handy when I'm attempting other types of problems. And this is what we want for our students. We want them to recognize similarities in things. So I couldn't have told you off the top of my head that it was a 2006 Cayley Olympiad, but I did remember the problem as soon as I saw Naveen's tweet. And then I had to look it up to just confirm which one it was. But I recognized it straight away and sort of mentioned my solution to Naveen there. So is this the same? Is this quite retrieval in the same sense where we're harnessing the testing effect? Maybe not. I might be sort of moving it a little bit away, but it is something that's maths relevant, related to maths, that I do think that we can take advantage of. Try and draw these links between these more involved questions. So just to finish off, I wanted to talk about retrieval and homework. So there's this balance to strike between homework that has sufficient support for students where they can actually complete and access and then complete the homework, versus homework that serves the purpose of retrieval. So if we just look at that second bullet point, do we want videos to be compulsory, or can we make them optional? Well, it depends. You'll know your classes. I'm not going to suggest one is better than the other. Compulsory videos might be a good thing if you know your classes haven't grasped the topic and it's a good way of getting them to learn. You might like getting them to take notes, like Hegarty would suggest. But you might have a class where from your lesson that they are fairly comfortable with a topic, in which case it's probably better if you set them online homeworks where they don't watch the video unless they absolutely have to, because that way you're forcing them to retrieve. Similarly, if you are setting homeworks that are always on the current topic, you are then not necessarily giving them opportunities to retrieve at home, which you may wish to do. And for that, you might want to mix up the topics on homeworks. And that's something that's really easy to do on some platforms, say Dr. Frost Maths. You can create mixed topics. Of course, if you're doing it an old school way and setting them worksheets or giving them textbook questions, well, with worksheets, you can mix up the topics quite easily. Textbooks, you'll have to tell them to go to various different pages, I guess. But it can be done. So I'm just talking about one-size-fits-all policies because it's a bit of a bugbear of mine. I've had to do certain types of homework or set certain types of homework to fit in with school policies in the past that I've not always agreed with. And one of those was, in fact, forcing students to watch videos. I didn't want to make them compulsory. That was my personal view. But also didn't want to go against what was the department policy at the time. All I would suggest, if you're in that position and you're interested in discussing, is if your leadership team or your line managers, whoever it is in your department, is willing to discuss the policy, you might want to raise the point. Otherwise, it's up to you whether you really want to rock the boat or not. So just a couple of things to consider there. So that's pretty much what I wanted to say on